Hi everyone, for today's video is all about Chapter 6 Network Layer. The first activity is about IP characteristics. Instructions: read each IP characteristics, then click connectionless, best effort, or media independent to indicate its delivery method. The first IP characteristic given is no contact is made with the destination host before sending a packet, so it is connectionless. Next IP characteristic is does not guarantee that the packet will be delivered fully without errors. It is in best effort. Next, packet delivery is not guaranteed. It is also in best effort. Then, we'll adjust the size of the packet sent depending on what type of network access will be used. It is in media independent. Next IP characteristic will send a packet even if the destination host is not able to receive it. Connectionless. Last, fiber optics, cabling, satellites, and wireless can all be used to route the same packet. Media independent. Next activity is about IPv4 header fields. It's the part 1. So, instruction, read each IPv4 header function and then click the IPv4 header field to which it belongs. First, IPv4 header functions. Always set to 0100 for IP version 4. Is in version. Next, identifies the priority of each packet. It is in differentiated services. Next, header functions identifies the IP address of the sending host. It is the source IP address because it says sending host, so it is the source. Then next, identifies the IP address of the recipient host. Is in destination IP address because the destination connected to IP address or in the recipient host. As you see in the source IP address, it is source IP address, it is the sending host. Then in destination IP address, it is the recipient host. Then next, commonly referred to as hop count. This time to leave. Wait, I click it twice, sorry. Next, identifies the upper layer protocol to be used next. This is the protocol. So I'm going to explain first. In version, it contains 4-bit binary value set to 0100 that identifies this as an IP or Internet Protocol version 4 packet. Next is the differentiated services, ephemerally called the type of service field. Then time to live or TTL contains an 8-bit binary values that is used to limit the lifetime of a packet. The next is protocol. Common values include ICMP and then TCP and UDP. The next is source IP address. Contains a 32-bit binary value that represents the source IPv4 address of the packet. Destination IP address contains 32-bit binary value that represents the destination IPv4 address of the packet. So next activity. Let's move on another activity. Next activity is about IPv6 header fields. In the last activity, it is about IPv4 header fields. So let's start. Instruction: read each IPv6 header description and then click the IPv6 header field to which it belongs. So the IPv6 is Internet Protocol version 6. The last activity is called IPv4 or Internet Protocol version 4. So the first IPv6 header descriptions, it is when this value reaches 0, the sender is notified that the packet was not delivered. It is hop limit. Okay. Next, identifies the size of the data portion of the packet. It is below then. Next, identifies the application type to the upper layer protocol. It's the next header. It is always set to 0110 version. It classifies packets for congestion control. It's in traffic class. To suggest that all packets receive the same type of handling by IPv6 routers. Flow label. So the answers are correct. Next, let's move on to another activity. The next activity in chapter 6 is about identifying elements of a router routing table entry. So in this figure shows that the A is T, then the B is 192.168.10 or 24, then C 90, 3072, D via 192.168.3.1, E is 000603, then NF gigabyte Ethernet 0/0. So instruction is a partial router routing table entry is shown. Each section of the entry is identified by a circled letter above it. Select the correct routing table entry section for each output. So before that, let's read first all the given statement. Number 1, the elapsed time since the network was discovered. Number 2, the administrative distance or source and metric to reach the remote network. Number 3, how the network was learned by the router. 4, shows a destination network. 5, the next hop IP address to reach the remote network. 6, the outgoing interface on the router to reach the destination network. Now let's start answering. In number 1, the answer is A. The gigabyte Ethernet 0/0. Then number 2, the administrative distance or source and metric to reach the remote network. This C or the 90/3072. Next, number 3, how the network was learned by the router is A. A is D. 4, shows the destination network. B the 192.168.10 over 24. Then the next hop IP addresses to reach the remote network is D, which is via 192.168.3.1 plus the outgoing interface on the router to reach the destination network. The answer is F, with the gigabyte Ethernet 0 over 0. So I said earlier that the E is gigabyte Ethernet 0 over 0, but it is 0.00603. Let's check if it is correct. So the answers are correct. Then we can move on to another topic, and to another activity. So the fifth activity in chapter 6 is about descriptions of router functions and hardware parts. Instruction: descriptions of router functions and hardware parts are provided in the table. Drag each router component named to its function or description. So the choices are wide area network interface, local area network interface, AUX port, telnet or SSH, then console port. So the descriptions here are, let's answer the first description. It connects routers to external networks, usually over a large distance. So it is wide area network interface. As you notice in the sentence, it usually over a large distance, because local area network, you can't use it. The best answer is wide area network interface, because it is wide, as you notice in the word given, wide. Next, a way to remotely access the CLI across a network interface. It is telnet or SSH. Oh, what happened? Telnet or SSH. Next, connects computers, switches, and routers for internal networking. Local area network interface. Because local area network interface can use in a small area, wherein you can connect computers, switches, and routers for internal networking. While the wide area network interface can use in a large distance and are not in a small area. Next is a local port, which uses USB or low-speed serial connections to manage network devices. This is the console. Oh, what happened? Console port. Okay. Then, a port to manage routers using telephone lines and modems. AUX port. Let's check if it is correct. So, my answers are correct. So, I can move on to another activity. The last activity in chapter 6. The last activity in chapter 6 network layer is the router boot process. As you see in the figure or in the given step-by-step procedure, you need to analyze the answers before you drag all the given choices here. So start, the instruction is Drag each of the steps on the left to appropriate field in the table on the right to show the router boot process order. So the given choices is load the iOS or the operating system file for the router loaded into RAM. After bootstrap, find the iOS file to be used. Next, perform post or hardware check performed by built-in ROM chip. Next, load the configuration file from flash or NVRAM, a TFTP server or go into setup mode to create a configuration file. Last, load bootstrap or copied from ROM to RAM locates the iOS. Let's start answering the router boot process. The step 1 you need to do is to perform post or hardware check performed by built-in RAM chip. Then after you do the perform post, in the step 2, you need to load bootstrap. Okay, it's happening again. You need, oh my god, it's happening. You need to load bootstrap. This copied from ROM to RAM locates the iOS. Then after you perform post, then load bootstrap. The step 3 you need to do is to load the iOS. Ay. You need to load the iOS. Or operating system file for the router loaded into RAM. After bootstrap, find the iOS file to be used. So the last step is to load the configuration file from flash. So the answers are correct. So, okay, I'm going to step by step again. So before you load the configuration file from flash, you need to go first from step 1. So the router boot process is to perform post. After you perform post, you need to load bootstrap. Then after you load bootstrap, you need to load the iOS. Then last is to load the configuration file from flash or the NVRAM. So that's all for today's video and thank you for watching. Bye!